Good morning. Today we will see about the extraction of lipids. In the last presentation, we have seen about the introduction to lipids. And here, when you just see the fixed oils and fats, they are extracted by expressing the plant and animal tissues. So, what do you mean by expression? That is, by applying pressure, the cells are broken and the fixed oil or fat which is present inside is coming out of the cell due to the pressure. So the extraction by expressing the plant or animal tissue is done by two methods. One is the Ghani method and hydraulic press. Ghani method is a very conventional and oldest method, and it is by means of mechanical method. And hydraulic press is the expression method by power driven motors. And another method of extraction of fixed oils or fat is nothing but the solvent extraction, as you know already, by using a specific solvent in which the fixed oil or fat is soluble, and later it can be removed from the solvent by appropriate methods. And first we will see about the mechanical method, or otherwise called as the Ghani method. This Ghani method or Ghani is otherwise called as Cheku or hole, where we will have a mortar and a pestle device in which the seeds are grinded into fine particles, and then the oil is extracted from it. So these ghanis, they are used extensively in the Indian subcontinent, where to get the oil from the vegetable seeds, especially the mustard, sesame, or coconut, or groundnuts. And in this case, the mortar will be a static one, or it is a stationary part, and where the pestle will be moving. And this pestle can be made out of wood or stone. And here in this Ghani, I had here kept the figure of a Ghani where the mortar is fixed on to the ground. It is a large vessel, and a pestle is there which can be made out of wood or the stone, and this pestle is moved within the mortar by the animal traction. The animals used usually the bullocks, and sometimes the donkey also can be used. And the seeds from which the oil should be extracted is placed in the mortar, and that will be moved along with the vessel will be moved, or it is power driven. And in the hydraulic press, if you see, the oil is first expressed with little pressure and with low temperature, which is called as the cold pressed oil, which has the commercial value, especially in case of your olive oil. When we see, we can say that virgin oil, the cold pressed oil, will have the more commercial value, and that can be called as a virgin oil. and the subsequent expressions by increasing little more higher pressure and higher temperature, that is of less commercial value, which can be used for the industrial purposes, and further they can be purified by treating with some clarification agents or filtration and so on. As I already told you, the oils also can be separated by using the volatile solvents, that is nothing but the non-polar solvents, where the fixed oils and fats have their maximum solubility. And after extraction with the non-polar solvents, the solvents can be removed by distillation process or by any suitable means to separate the fixed oil and fat from the solvent what you are using it for the extraction. So that is about the extraction of the fixed oils or fats, that is by the three methods. One is the mechanical method called as Ghani method, and the one which is driven by the motor, that is called as your hydraulic press, and the third one is the solvent extraction method. And another class of lipid apart from fixed oil and fat are the waxes. These waxes are nothing but they are the esters of long chain fatty acids with high molecular weight monohydric alcohols. And the fatty acids are same in case of waxes and fats, but they differ in their saponification process. Waxes can be saponified only by using the alcoholic alkali, whereas the fats can be saponified by using the alcoholic alkali or aqueous alkali. Along with the fatty acids, they contain a monohydroxy alcohols which has the higher molecular weight. The examples of this high molecular weight monohydric alcohol are cetyl alcohol, malicyl alcohol, and myrcyl alcohol. And this waxes sometimes they contain cholesterol or phytosterols. And these waxes are not suitable for taking inside as a foodstuff because the hydrolyzing enzyme for wax are not present in the biological system. And these waxes are widely distributed in nature. The leaves and fruits of many plants have the waxy coatings, which you might have observed when you just touch the surface of the leaf. Especially the example what you can see your lotus leaf, where the water will not stay over that. The wax covering over the leaves and fruits will protect them from dehydration and also from the small predators. Sometimes the feathers of the birds or fur of some animals will have the similar coatings, and they serve as the water repellents. Especially when you see the sheep, the wool of the fleece of the sheep, which is completely covered with the waxy material from where you are obtaining the wool fat. The waxy substances will give you the wool fat after cleaning. That's what we are going to see in later. And the examples of this waxes are spermaceti, beeswax. These are the examples of wax from animals. And carnauba wax and the sessile wax, they are the examples from the plant source. So that is about the waxes. And next we will see about the pharmacognosy of lipid containing drugs. So under that, first we will see about the castor oil. All of you know very well about the castor oil, and this is the oil which is obtained from the seeds of the castor plant. So in Bangalore, if you see, these castor plants are very highly present on the roadsides and the other places. So this castor oil, chemically, it contains the lipids, and it is pharmacologically used as a laxative or a purgative. And morphologically, it is an unorganized drug because it is a fixed oil which is expressed from the seeds. So it is an unorganized oil. Can you just see the synonym of castor oil? It is otherwise called as castor bean oil or castor oil seed. It is the seeds, if you say, or it is otherwise called as Oleum ricini or ricinous oil or oil of Palmagrusti or cold ground castor oil. These are all the other names by which the castor oil is called. And next, when you come to the biological source, it consists of the fixed oil obtained by cold expression from the seeds of Ricinus communis belonging to the family Euphorbiaceae. And geographical sources, it is mainly indigenous to Brazil, which is the very world's #1 producer of castor oil, and secondly India. And apart from this, the other places where the castor oil is produced is America, China, Thailand. In India, it is cultivated in Gujarat, Andhra Pradesh, and Karnataka. And next, when you just see the preparation, the fixed oil from the castor seeds can be expressed by two methods. One is the Gani method and the hydraulic press. You know very well, the Gani method is the mechanical method where the vessel is driven by the bullocks or the donkeys sometimes. And in the hydraulic press, the oil is expressed by the power-driven motors. The oil can be expressed from the castor seeds, either from the decorticated seeds or the whole seed. If you are expressing the oil from the decorticated seeds, the seeds are subjected to the stone grinders where the seed codes are crushed and they are removed by winnowing or by subjecting it to a current of air to remove the testa and the endosperm. Then the kernels are collected and fed into the oil expellers, that is nothing but your hydraulic press. And at the room temperature, by applying 1 to 2 tons per pressure square inch, the oil is expressed. At this condition, about 30% of the oil is expressed. That is called as your cold ground oil. And the oil which is collected by this method is collected. It is subjected for filtration. And after that, it is steamed at 80 to 100 degrees centigrade to initiate coagulation and precipitation of the poisonous principle, ricin. It is a protein and an enzyme lipase present in it. If they are not removed, the lipase will allow the oxidation of the fatty acid, which makes the oil rancid, and this toxic substance may affect when it is taken internally. And when this oil is filtered and obtained, you will have the acidity of about 1%, which can be used for the medicinal purposes. The remaining mark or the oil cake, which contains your resin, lipase, and about 20% of the oil, and this cake is grounded well and steamed at 40 to 80 degrees, and again subjected to 3 tons per square inch pressure, and the oil is extracted. And the oil obtained by this method, but by slightly increasing the temperature and increasing the pressure, it is having the acidity of around 5%, and it is used only for the industrial purpose. And the lift out cake will contain around 8 to 10% of the oil that can be further extracted by using the lipid solvents. And that is also can be used for the industrial purposes. And the residual cake is used as a menu, and they are not fed to the animals because they contain a toxic principle called as resin. Or sometimes the left out cake is used for the production of lipase. So that is the production of castor oil from the castor seeds. And next is the morphological characteristics. So this castor oil, it is colorless or slightly yellow colored in nature. It is a viscid liquid with a slight characteristic smell and acrid taste. When you just come to the solubility of the drug, it is absolutely soluble in absolute alcohol in all the proportions, especially 1:1, it is freely soluble, and also soluble in the other organic solvents and insoluble in water, as usual, the solubility of fixed oils. And when you just see the standards of the castor oil, the specific gravity is 0.958 to 0.969 with a refractive index at 40 degrees 1.46952 1.4730, and the acid value is not more than 2, saponification value between 177 to 187, and acetyl value is 150. These are all the standards to which it has to comply. And when you just come to the chemical constituents of the castor oil, it consists of the triglycerides of ricinoleic acid and isoricinoleic acid. These are the major components or the fatty acids present. And apart from ricinoleic and isoricinoleic acid, it also has the triglycerides of stearic acid and dihydroxystearic acids. And this ricinoleic acid and isoricinoleic acid are responsible for its laxative property. How this is responsible for its laxative property, when you just take the oil, it gets metabolized in the GIT. Ricinoleic acid is liberated from the triglyceride, and this ricinoleic acid causes irritation in the bowel, and thereby it causes evacuation of the bowel. So where it is helpful in constipation. And apart from the triglycerides of these fatty acids, the castor oil also contains vitamin F. So in the total content of triglycerides, around 90% of ricinoleic acid is present out of the total fatty acids. And this ricinoleic acid, usually it has 18 carbon atoms in its chemical structure, and has one double bond in the 9th and 10th position of the carbons and an hydroxyl group on the 12th carbon. The combination of this two things, that is the presence of hydroxyl group and unsaturation, occurs only in this castor oil. And when you just come to the identification test for castor oil, about 5 ml of light petroleum is mixed with 10 ml of your castor oil, and below 15.5 degrees Celsius, it gives up the clear solution. Even if it is stored in the refrigerator or at 0 degrees centigrade, the solution remains clear. As I already told you in the solubility, it is freely soluble with equal amounts of its alcohol. And next is the uses. It is used as a mild purgative, fungistatic. It is used in the preparation of ointment bases, and it is used as a plasticizer, as a wetting agent, and as a lubricating agent. This ricinoleic acid is also used in the preparation of contraceptive creams and jellies. And it is used as an emollient in the preparation of lipsticks and in tooth formulation. It is also one of the ingredients in hair oil. It says that it stimulates the hair growth. Usually when you see in the villages, they apply castor oil once in a week to the hair, and then they just take the head bath. So that's why in the olden days or in the village sites, the hair growth was very good, and they used to have a very long hair and thick hair. Nowadays, if you see, the condition is getting reversed. The hydrated oil is used in the manufacture of linoleum and an alkyl resin, and in the industrial purpose, the oil is used for coating. And apart from that, in the pharmaceutical industry and in the preparation of cosmetics, in the preparation of soap, castor oil is used. And also it is used in textile and leather industries. And also it is employed in the manufacturing of plastics and fibrous materials. So that is about the castor oil, and some forms of the castor oil like hydrogenated castor oil or dehydrogenated castor oil. All these things are used especially in the industrial purposes. And the marketed products, if you see, it is one of the ingredient in the preparation of lip balm and muscle and joint rubs, especially in the various preparations produced by Himalayan drug companies. So that is about the pharmacognosy of castor oil. And next we will see about the Chaulmoogra oil. Morphologically, this Chaulmoogra oil is an unorganized drug, which is a fixed oil, and chemically it contains the lipids. It is a triglyceride of fatty acid, and pharmacologically it is used as an anti-leprotic agent. Synonym: it is otherwise called as hydrocorpus oil or gynocordia oil. Biological source: it consists of the fixed oil obtained by cold expression from the ripe seeds of Teratogenous furze or Hydrocorpus furze, and also from Hydnocarpus victiana or Hydnocarpus anthelmintica or Hydnocarpus heterophylla, another species of Hydnocarpus belonging to the family Flockertiaceae. So it consists of the fixed oil obtained by cold expressions from the seeds of Terractogenous cursi, or otherwise called as Hydnocarpus cursi, or Hydnocarpus victiana, Hydnocarpus anthelmintica, Hydnocarpus heterophylla, and other species of Hydnocarpus belonging to the family Flockertiaceae. And next come to the geographical sources. It is native to Burma, Thailand, Eastern India, and Indochina. And it is a tall tree which grows to an height of about 17 meters. And they have the narrow crown and the hanging branches. That is a characteristic features of the tree. And usually the production, if you see, it is already from the seeds the oil is expressed by using the hydraulic press. And next, the morphological characteristics. The oil is pale yellow or brownish yellow in color, which becomes a soft solid at low temperatures. It has the characteristic peculiar smell and a sharp taste. Then you just see the solubility: insoluble in water, soluble in organic solvents like benzene, chloroform, ether, and petroleum ether. As usual, it is slightly soluble in cold alcohol and it is entirely soluble in hot alcohol. And also it is soluble in carbon disulfide. And when you just see the chemical constituents of Chaulmoogra oil, it consists of the triglycerides of cyclopentenyl fatty acids. That means which has the 5-membered ring with one double bond inside the ring, and in the first position it is attached with the carbon atoms. The examples or the various cyclopentenyl fatty acids present are hydnocarpic acid, chalmoogric acid, and gorlic acid. About 48% of hydnocarpic acid is present and 27% of chalmoogric acid. And apart from the triglycerides of these three cyclopentenyl fatty acid, it also has the triglycerides of palmitic acid and oleic acid. And this cyclic acids, usually they are formed in the seeds just before 3 to 4 months of the maturation of the fruit. And they have a strong bactericidal effect towards the Mycobacterium species, especially Mycobacterium leprae. And the seeds of Hydnocarpus victiana, they contain a flavonolignan, that is the flavonoidal compounds. They are hydnocarpin, isohydnocarpin, methoxyhydnocarpin, epigenin, luteolin, chrysoriol, hydnovictin, epivolcanin, and cyclopentenoid cyanohydrin. These are all the flavonoidal glycosides which are present in Hydnocarpus victiana, apart from the above mentioned glycerides of fatty acids. So that is about the chemical constituents of Chaulmoogra oil. And the uses: the oil is useful in the treatment of leprosy and many other skin diseases. The cyclopentenyl fatty acids of the oil, they exhibit specific toxicity towards the Mycobacterium leprae and Mycobacterium tuberculosis. And now the oil has been replaced by ethyl esters and the salts of hydnocarpic and chalmoogric acids. And this organic sulfone derivatives of these oil has been replaced in the therapeutic use. Usually, this Chaulmoogra oil is not intended for the internal use as it is highly toxic. So it is especially used in the external formulations. So that is about the pharmacognosy of Chaulmoogra oil. The structures of this cyclopentenyl fatty acids you can refer from the book, that is the textbook of pharmacognosy by Coquette. So here we stop the class. Thank you.